Okay guys, this is 5.4, point slope form of a line. Last time we talked about slope intercept form, which was y equals mx plus b. This is the second of three different ways to write a linear function. So you need to make sure you have this written down somewhere in your notes. We've got point slope form is y minus y sub 1 equals m times x minus x sub 1, where the x1 and y1 represent a coordinate that the line goes through. So this x sub 1 here and y sub 1 here would be written like this. Some coordinate, it might be a point. We're going to look at an example down below here. And then m is the slope. And that's all we need. We're going to plug in something for y1, something for m, and something for x sub 1, and then we can leave it there sometimes unless we're asked to change it back to slope-intercept. So here's an example. We're going to write an equation in point-slope form that goes through the point 4, -2. So 4, -2, that's my x1, there's my y1, and has slope of 7. 7 is my m. So we're just going to plug in as we go here. So I've got y minus y1, which is -2. I'm replacing the y sub 1 with -2 from over here. And then I have equals. I'm going to replace m with 7. And then I'm going to replace x sub 1 with the 4 right here. And then I just clean it up. Bit. When I say clean it up, I mean I have this y minus a -2, which is the same as y plus 2, equals 7, and then I have x minus 4. And that is it. That's the equation of a line in point-slope form. All right. So let's move on here to another example. It says writing an equation in point-slope form. A line passes through -3, 6 and has slope -5. Let's try another one here. So we're going to make it match y minus y1 equals m, x minus x1. We're going to actually plug in all the information we have. We have x1 here, y1 here, m right here. So I have y minus 6 equals -5, x minus a -3. And the cleanup would look like this. Y minus 6 equals -5, x plus 3. That's it. So I'm going to have you guys try this one down here and put in what you think the equation is in point-slope form. So you guys are going to do that on your own. Problem 2, it says graphing using point-slope form. So given an equation in point-slope form, we can figure out the graph. Here's how it works. It's kind of similar to what we did with y slope-intercept form, but instead of having the y-intercept, we are given a specific point that is on the graph, and it's not necessarily right on the y-axis. So 2 is my y sub 1, and 1 is my x sub 1. Now keep in mind, the formula has minus signs in it, so those must be positive values. In other words, the coordinate of x sub 1, oops, I did this backwards. That's x sub 1, and this is y sub 1. Sorry about that. So this is y sub 1 here, and that's x sub 1 over there. So remember that the equation is y minus y sub 1 equals m, x minus x sub 1. The equation has minus signs in it. So if you have minus signs here and here, then that means the original point is positive. That's a +2 and a +1. So my coordinate is 2, 1. So I go over here to the graphing grid. I go over to the right 2 and up 1. And place a dot right there. So I know my line goes through the point 2, 1. My slope, m, is equal to 2/3 because that is in the place of m in the formula. So 2/3 is my slope. So starting from this point over here, I go up 1, 2, and I go right 1, 2, 3, place a dot there, draw my line, and that's it. So you can graph a line given the equation in point slope form. It's not too hard. You got to locate the point, place a dot there, and then do what the slope says. I'm going to do one more here. You're welcome to pause the video and just try this one on your own. I'm not going to have you graph it on your own. It's part of your notes. But it says, what is the graph of the equation? Y minus 7 equals negative 4/5 x plus 4. Now remember, my equation would have had to have been this. Because of the minus sign in there, it would have been in this form originally. So the x minus a negative 4 is what gives me a plus. We're going to end up taking x1 to equal the opposite of the sign you're seeing in the formula for that reason. So x sub 1 is negative 4, y sub 1 is equal to 7, and m is equal to negative 4/5. So I've got the coordinate negative 4, 7 is where I'm going to start. So I'll go 4 left, 7 up, place a dot there. So from that dot, go down 1, 2, 3, 4, and write 1, 2, 3, 4, 5. Place a dot there, draw the line through. So I wanted to show you that example because of this guy right here. We've got the plus sign in there, so the actual value of x sub 1 is negative 4. It's the opposite of that sign. All right, it says using 2 points to write an equation. It says, what is the equation that represents the line in the graph? So let's see if we can do this one. We've got 2 coordinates, one here at negative 2, negative 3, another one at 1, 4. We're going to go through the process of writing the equation of the line like we did with slope-intercept form, but we're going to do this in point-slope form. So y minus y1 equals m, x minus x1. The first step is exactly the same as what we did when we wrote the equation of the line in slope-intercept form, and that is find m using the formula y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So it's my choice over here. I'm going to choose the 1, 4 to be my x sub 2, y sub 2. It's farther to the right. I'm going to choose the negative 2, negative 3 to be my x sub 1, y sub 1. It's the first point as I go from left to right that I come across. Plug this in here. So m equals y sub 2 is 4, y sub 1 is negative 3, x sub 2 is 1, and x sub 1 is negative 2. So I've got this slope, m equals 4 plus 3, the minus the negative 3 is 4 plus 3, and 1 plus 2, which gives me 7 over 3. All right, so here's what I have so far. Let me take all this, whoops, try it again. Take all this right here, and I'm going to group it together, move it over here. So there's my calculation for slope. We'll just move that to the side. Now what I want to do is get the equation of the line here. In point slope form. So here's what I know. I know m is equal to 7/3. So I can put 7/3 in for m. I need to now pick a point, just like we did with slope-intercept form. And I'm going to pick one of these points. I guess, you know, if I labeled the point x1, y1, I should probably use this point right here. It's, well, we'll get into this in the next question here. But we're going to go ahead and use x1, y1 as negative 2, negative 3. So I'm going to plug in negative 3 for y1. It's this guy right here. And I'm going to plug in negative 2 for x sub 1. That's this guy right here. And go ahead and clean that up. Y minus a negative 3 is y plus 3 equals 7/3 x plus 2. And there is one version of the equation of a line in point slope form. Let's look at this question here in the Now You Try. Consider it. It says in the last step of problem 3, use the point negative 2, 3 instead of 1, 4 to write the equation of the line. Now we use negative 2, 3, so we're going to switch it up here. we're going to use the point 1, 4 instead of the point -2, -3. Okay, so here we go. Here's what it would look like. Instead up here, so take a look up here, instead of putting in -3 and -2, we're going to put in the point 1, 4. So I have y minus 4 equals 7/3 x minus 1. Okay. Now, the question is this equation right here the same equation? Does it have the same graph as the equation I did up above, right up here? Do they have the same equation? Well, it might be kind of difficult to see at this point, but there is a way to check to see if these are both the same equation, and that is to go back to what we did last section and write each of these in what's called slope-intercept form. So let me change colors here. I'm going to take the first one, that's this guy up here, and rewrite it in blue. Y plus 3 equals 7/3 x plus 2. And then I'm going to take another color, maybe green, and I'm going to write this guy over here in green. Y minus 4 equals 7/3 x minus 1. And what we're going to do with each of these is solve them for y, or get them in slope-intercept form. So here's what this would look like. I distribute the 7/3, so I have 7/3 x plus 2 times 7 is 14 all over 3. And then I'm going to subtract 3 from each side. So I've got y equals 7/3 x. Think of this as 14/3 would be the same as 4 2/3. And so I have 3 goes into 14 4 times with 2 left over. So 4 2/3 minus 3 gives me 1 2/3. So I have plus 1 2/3. Usually in math we won't write the mixed number there, but it's helpful to have it as a mixed number if I were to graph it. So another way you might see this written is y equals 7/3 x plus 5/3. That's probably how you'd see it written. Remember, the trick is to take 1 times 3 and then add 2 to it to get the 5, and then put it over the denominator 3. All right, so there's my one equation. That was when I plugged in the -2, -3 for my x1, y1. Let's see if it's equivalent to my other equation when I plugged in the 1 and the 4. So what I do here is distribute the 7/3 again. And then this time I'm going to add 4 to each side. So I've got y equals 7/3 x. Let's think of this guy, 7/3, as 2 1/3, because 3 goes into 7 twice with 1 in the remainder. And then we're going to add 4 to that. So I get 6 1/3 here. I'm making a mistake here. Oh, it's a -2 1/3. Okay. Say it shouldn't be 6 1/3. They really should be equal. So the question is, what is -2 1/3 plus 4 equal? Well, 4 minus 2 1/3 would be 1 2/3. It's looking kind of familiar. Like this guy over here. If I change 1 2/3 over to an improper fraction, I get y equals 7/3 x plus 5/3. And you can see that these two equations in green and in blue are exactly the same thing. Now, go back up to the graph here. I mean, it doesn't matter which point I use, the 1, 4, the -2, -3, they are both on the same line. And so it makes sense to me that they have the same equation. What's happening here and here is this is just a different form of the same equation, but it is the same equation. And we can see that by comparing the slope-intercept forms of those two equations. So slope-intercept form is just a different way of writing the equation of a line. When you graph it, you get the same line. All right, we've done some of that. We've looked at tables and written equations from tables, so that's it. Hope that was helpful for you. You're going to do some problems just like the ones I did in the book working out.